is one of the most commonly asked interview questions in many companies, especially if you're going, all companies which come for generic fresher profiles, and especially in college campus recruitment and all, commonly asked question this is. Why? Because it just checks your understanding of recursion. Now let me recursively write the solution for you and see, guys, now you must start thinking how to come up with a solution. Don't understand my solution. Now try to think how I am thinking. How am I thinking to give it a recursive solution? So watch it. You want to write a program to reverse a string using recursion. What I will do is, let us assume this is a string ABCD. You want to reverse it. See, reversing means last character should come first. So obviously, don't you think you must have a reference or somewhere from where you can start from the end of the string. You must always begin from the end of the string if you're doing reversing. So what I will do is, I'll write a function to which I will pass my string, and I will also have another variable, let us assume I, which is going to have the last index or the index of the last element in the string. And what is the index of the last element? I'll call this as S. Index of the last element is nothing but 3. But before that, don't you think strings are immutable in Java? They are immutable. If they are immutable, don't you think you can't modify this string? You have to have another string. So to reverse the string, I'm going to have an empty string called as R. S is the string which is passed, R is the empty string. Next thing is, I will also have I, which will always have the index of the last character, in this case which is nothing but 3. How to give that we will see. Now it's very simple. How I will be recursively solving this is very simple, guys. Right now my string is ABCD. What I would like to do is, when I call this function again, initially string is S, empty string is R, but I would like to take the character present at the ith position, concatenate it with R, and then when I'm calling the string again, this string is immutable, so I have to pass the same string only. But what I will do is, I don't want to look at the complete string. I want to look at only the string minus the last character, which means ABCD if I have. Now I want to think the string as ABC. But I cannot remove the last character. All that is not possible. You cannot remove the last character. But I can move one position behind. I is now at D, but I can move to C. Would you agree with me? So see, this is what I am showing you. I is now at the last character. What I will do is, I will again call the same function. I will pass the same string yes, but while passing, what I will do is, in the previous call I was at the last character, I will take the last character, the element present at the last character, concatenate it to R. And then I value, which was 3, in the second call I will subtract 1 and send. So it becomes 2. See here, it became 2. Any confusion till this point of time, guys? Whatever I spoke, is it crystal clear to all of you? Yes, sir. Next what, you might ask. Next what means, again same thing. I'll again call this. When I call, string is the same. But in the previous call, I was at the second character. Whichever character I is at, I will concatenate it to R. So R was D. When I concatenate to it, it will become DC. And then I value I will reduce. I was 2 here. I will reduce and send. So I will become 1. Any confusion till this point of time? Then what happens is, I will again call the same function. When I again call the same function, this time string is the same. But I will concatenate whatever is there at the ith position, reduce the value of I and send. So I was 1 here. In the next call it should become 0. See, it became 0. Again what I will do is, I will again call this. This time, obviously I became 0, so I'm moving it here, right? Now, again if I call this, then what will happen is, whatever is the character at the ith position, concatenate it with R and send it. So R will become BCBA. Then what will happen is, I value you have to always reduce. Here it is 0. If I subtract 1 and send, I is going to become minus 1. If I becomes minus 1, it comes out of the string. It comes out of the string. If it comes out of the string, now there is no more point in continuing. Which means, don't you think I've hit the base? This is only my base condition. And how will you define the base condition? Base condition, is it defined using yes? Is it defined using R or is it defined using I? Put it in the chat if you have understood. How can I define the base condition? Using yes, R or I? Absolutely. And what is the base condition? The moment I goes out of the first index. First index is 0, which means, don't you think if I can write, if I becomes less than 0, then I have hit my base condition. Now if I hit my base condition, what should I do? What I should do is, see, R is the reverse string. As it is, send that reverse string, return that reverse string. I hope I am clear. So I will return R. That is what I will return. Same R, even this fellow will return. Same R, even this fellow will return. Same R, even this fellow will return. So that is what I am also showing you. Same R will be returned. And ultimately, what this will get is that reverse string, which is DCBA, and that is your answer. Now, if this was asked in any of the companies which you have attended, maybe if you knew the solution, you could have written it. And imagine to the interviewer, if you would have traced like this and shown, he would have immediately selected you. At least I would have selected you. But I am not the interviewer, so I will not select you. Okay. Anyways, now let us go and write the code here. So I'll minimize this also and keep sum of digits. Remove these lines except for scanner, last 2 lines you remove. Yeah. Now I will go there and I'm going to create static. What this has to return is a string. So string, and it's a reverse string is the name of the function. Also, maybe if you want to see what is the recurrence relationship here, okay, have we defined it here, the recurrence relationship in this? Just check. Yeah. So see here, if you want the reverse string, where you will pass yes, R and I. Yes is the string, R is the empty string, I is the index of the last character. So before that, I should first call reverse string, pass the same string yes, but to R, concatenate the character present at the ith position, and then decrement the value of I by 1. I hope you are able to think. And see, that is what I am also going to write here. If I go here, I am going to tell, so string yes, and then string R, which is an empty string, and then int I. So inside this I will come, first my base condition. If in case I value becomes less than 0, then it has gone out. Return, what to return? If it becomes less than 0, see R, it would have had the reverse string, so return R. Okay, then I will come here and next what I am going to do is, of course here then comes the recursive relationship, so I will tell return, and what to return? What to return is call reverse string again recursively. This time yes is the same, remove that, all that. Reverse string, inside that as it is yes I will send because it is immutable. But to R the next time, I don't want to send the same R. See, I want to concatenate the character present at the ith position and send it to R. So see, R plus, concatenation means plus, character at the ith position. How? Yes dot char at, because you know direct access is not there. Yes dot character at the ith position, comma, I value will initially be at the last index. Now I have to bring it one step back. So I will tell I minus 1 like this. I hope you are able to think. Any confusion? So if I is 3, it will become 2. If I is 2, it will become 1. I hope till here, whatever I spoke is clear to each and every one of you. Now let's go down. And here I will just take a string. So I will just tell scan.next. And that I will store it in a variable called as yes. Now see how I will call system.out.println. And here I will tell, I will call reverse string. When I call reverse string, don't just type it. I'll call reverse string. And in reverse string, inside this, what I'm going to do is, I will pass yes. I will pass yes. That is my string, comma. Now, Initially, what should be the R value? It should be an empty string, correct? Empty string, how will you pass? Simple. Open double quote, close double quote. That's it. That is empty string. Even if you leave a space, it is not empty, remember. Comma. I value should be the index of the last character. How will you get the index of the last character? Simple. Yes dot length if I tell. I will get the length of the string. If the length of the string is 4, last index will be 3, so -1. How many of you understood this properly? Put a yes in the chat if you understood this properly. Beautiful. Good that if you have understood, I am very happy with you. Now let us go and execute it and see whether it will work. Okay, so if I execute it, cool. So now the string, maybe I will tell LMNOP. If in case I press enter, you can see PONML. It works. It works with perfection. So I hope reversing the string is also clear. But if I re-execute that program once more, watch it. Now I will just re-execute it. This time I will put MADAM. If I press enter, oh, it didn't reverse. Same thing I have got. Can someone tell me why I got the same thing? Who can tell me? Did it reverse or did it not reverse? Good. 100%. This is a palindrome. Why I purposely gave a palindrome as input is because the next program, which I am going to give you 2 minutes time to think about and provide a solution, is to write a recursive program which can check if a string is a palindrome or not. Take 2 minutes time, think about it, and I will come back and give you the solution. Okay. How to give a solution for this? Understand what I am trying to say and understand it carefully. Okay? Brains you have to use. Recursion is not easy. Why it is not easy is because it is new. It is not that it is difficult. It is new. The more you practice, easier it will become. So watch it. First thing that I would like to do is, I would like to basically check if a palindrome, if a string is a palindrome using recursion. How am I going to do this? It's very simple, guys. There are few cases you must understand. I'm beginning with case 1. In my case 1, let us assume I write a function to which I pass my string, which is a palindrome in this case, because you know madam is a palindrome. Obviously, these are the index values 0, 1, 2, 3, 4, and we will call it some reference. Maybe I will call it as yes. Okay. Now the thing is, palindrome means what? In the forward direction same, reverse direction same. If in the forward direction and reverse direction it is the same, then don't you think first character, last character must be same? Don't you think second last character must be same? Same. That is one way of checking for palindrome. Would you agree with me? So, or other ways to reverse the string. That is inefficient way. After attending so many of these programming classes, you should not even think in those lines. Okay? Which means, before I even apply any kind of logic, first thing I would like to see is whether the string is a palindrome or not. First thing I can immediately in one step check and tell whether it's a palindrome or not, which is check the first character, check the last character, see if they are equal. If they are unequal, there itself I want to tell, no, it is not a palindrome. False I want to return. I hope I'm clear. So I must keep track of first character, last character. How will I do that? By making use of I, which will always have the first character's index, and making use of J, which will always have the last character's index. And the first thing which I will always do to check if it is not a palindrome is, see, yes dot caret of I will check. Yes dot caret of I, if I check, that is nothing but that character, right? That is I, that is J. I will check if the character at the ith position and character at the jth position are equal, like this. You know it is equal, both are M and M. Only if it is equal, then I will do anything else. Okay sir, it is equal, now what you will do? Now what you will do is, the entire concept of recursion is to try to break it down into smaller problems. Now the entire string madam I took, right? ij is here. I want to make it into a smaller string. How will I make it into a smaller string? I will increase I by 1, I will decrease j by 1. If I increase I by 1, it is A. If I decrease j by 1, it is A. So don't you think madam has become ADA now? It's a smaller string. Again, I will recursively call that. How many of you understood this? Put a yes in the chat. How many of you understood how I am breaking it down into a smaller problem? Same people keep putting yes. Others, I know, you will be sleeping in your bed, you would have kept the phone somewhere and yes sir, okay sir, whatever sir. I hope you're all ready, awake and listening and are digesting the knowledge given to you. Because after all this is not for me, it is for you, remember. Who paid money is not me, it is you, remember. Who took money from their parents is not me, it is you. Who needs a job is you, not me. So who should be alert is you, not me. Keep always that at the back of your mind. Anyways, now this is how it is. Now what is going to happen is, see, recursively I am going to call the same function. String is immutable, same string I will pass. But what I will do is, I value, I will increase it by 1. J value, I will decrease it by 1. So I is 1, j is 3. Which means here, I increased by 1. J decreased by 1. I is 1, j is 3. Now my string that I am working on is ADA. Though it is madam, I and j has allowed me to shrink it, reduce it. First step is always check whether it is a palindrome. How? Character at the ith position, character at the jth position must be same. If I check, 100% they are the same, which means I am still, even now it is a palindrome. Now I would like to reduce the size of the string even more and check if that string is a palindrome. How? Call the same function again, pass the same string, but increase I by 1, decrease j by 1. Which means, see, if I increase I by 1, it moves forward. If I decrease j by 1, it moves in the reverse direction. And now I and j have collided. I and j have intersected. If I and j have intersected, it means my string, I have reduced it and it has become just 1 character long. Obviously, if I check my condition, is character at the ith position equal to the character at the jth position? I will get true because yes, there is only 1 character. So, don't you think the moment I hit 1 character, I must stop? This is my base. Wouldn't you agree this is my base? Now, how will I define the base? Will I define it using yes or will I define it using I and j? Put it in the chat. Yes or I and j. How can I define the base condition? Ij. What is the relationship I can write here? Put it in the chat. What is the relationship? I less than j, I greater than j. What is it? I equal to j. Perfect. So the moment I and j become equal, base. Which means it is a palindrome. If you hit the base, it means it's a palindrome. Which means return true. Right? This is my base and that's what I'm showing. I equal to j. Now I will return true, return true, return true like this. Now coming to the second case, ABBA is my string. So these are the index values. This is my string, yes. Now I have I and j obviously to help me. I will always have the first index, j will initially have the last index. In this case also, j is 3 this case. Okay. Now first thing is check, is it a palindrome? How? Character at I, character at j. Is it equal? And obviously a and a are equal. Which means now I will recursively again call the same function by passing the same string, but I will increase the value of I, decrease the value of j. I becomes 1, j becomes 2, and I am showing, see, I becomes 1, j becomes 2. Again check, is character at the ith position, character at the jth position the same? If I check that, of course, yeah, j has moved. So if I check that, as you can see, they are equal, which means it is still a palindrome. Now again I want to shrink the problem. So what I will do is, now look at this, is interesting. I will again recursively call the same function. Now I and j are here. You must increase the value of I, you must decrease the value of j. I becomes 2, j becomes 1, which means here I moves forward, j moves backward. I went here, J came here. But if this happens, then even now, this means it is a palindrome. It is a palindrome. I hope you're able to think, guys. It is a palindrome. Here there were odd characters, here there were even characters. If there are odd, if it is a string which is an odd number of characters long palindrome, this is your base. But here, don't you think if I check is yes dot character of I equal to yes dot character of j, I will still get equal? Now, this is also a base condition. But who can tell me what should be the base condition here? So, one second guys, please understand. Don't ever think that when you are writing recursion, base condition will only be one. Sometimes there can be many base conditions, and this is a very good example to prove to you that this is a problem which has more than one base condition. What is the base condition here? Okay. Okay. Okay, fine. All right. Anyways, let me get back. So basically, guys, I can write it like this. This is my base condition. I'll just write it like this. That here, what I can write it is if j becomes less than or equal to I. I hope I'm clear. See, j became less than I. Now, don't you think these two conditions are nothing but one and the same? Both can be merged as one and written. J less than I will satisfy this. J less than equal to I will satisfy this also, because I and J are equal. So don't you think instead of writing two conditions, both are nothing but the same. So this satisfies this also. So this is nothing but our base condition. Base condition for what? When the string is a palindrome. But if it is not a palindrome, you don't even have to worry, because every time when you call the function, first thing you check is if the first character and the last character are the same. That is nothing but the base condition for a non-palindromic string. The moment that becomes false, you will return false. How many of you understood these both are the same and the non-palindromic string condition? Put a yes in the chat. How many of you understood? Okay, good, fine. Let's go and now write. Just go back here. Now let us go and write the code for this. So watch it. Here, what I am now going to do is in my editor, I'll just reduce this function and keep it. Okay, and here I'll just go and I will tell a static. Now the thing is, we are writing if it is a palindrome or not, right? So Boolean is what it should return, true or false, yes or no. I'll call this as is palindrome. Is palindrome, palindrome spelling, Palindrome, is palindrome. And first thing is, it will accept a string yes. It will accept an integer variable I, which will have the starting index. It will have the integer variable j, which will have the ending index. Inside this, I will go first my first base condition, which is for non-palindromic string. How will I do that? If in case the character present at the ith position, so yes dot charac of I, is it equal to the character present at the jth position? Yes dot charac of j. Okay, is not equal to, you can check, not equal to. If this is the case, then if it is not equal, then what it means? It's not a palindrome, which means I will return false. Yes, it's not a palindrome, return false, I will tell. Otherwise, if it is true, I will not return anything, I will come down. Again, I will recursively call is palindrome. Is palindrome, again spelling mistake. Is palindrome, and to this I will pass the same string. Strings are immutable, I can't modify. But how will I reduce its size? Very simple. Increase I by 1, I plus 1. Decrease j by 1, j minus 1. I hope I'm clear. Okay. But before this, shouldn't you check for one more base condition? But anyways, whatever this gives, I will return it. I will tell return. But we did not write the base condition for when it is a palindrome. When should it stop recursion? When this condition, if in case j value becomes lesser than or equal to I. If that is the case, then I know I've hit my base, it is a palindrome, so I'll return true. So here, return true. In this case, no need to tell return here. You have to, because otherwise how will the control come back? You have to tell return here. Any confusion till here, my dear friends? How many of you understood this code perfectly? Please put a yes in the chat if you understood. It's very important to me you understand this recursion. That is how you can get placed in really good companies. This is the difference between a person who goes and reads some previous year question papers, practices, mugs up some code and goes, and a person who understands the concept. And I want you to be the person who understands the concept, because only then can you get your first job, sustain in the job, grow in the job, and grow in your career. See, there are many ways to get a job. You can pay someone money. Sometimes, people do all that. They pay, they take backdoor entry and all. They will make someone else clear the written test for them and they will get into the company. There are some people who by absolute fluke will get into the company. That program which he knew only was asked in the coding round. Few questions which was asked, which he wanted to know only was asked in the coding round, and he may clear, right? But when these people go and actually start doing the job, they will realize that they could have fooled an HR, they could have fooled the recruiter of the company, but they can't fool life. Life will start fooling around with them. When their project manager gives them a task to do, they are unable to do it. When a requirement specification is asked to be converted into a design specification, and when it is asked to be converted into code, they cannot do it. They cannot go to Stack Overflow and understand the code written by another developer and reuse it in their program. They realize they are not able to debug the program. They realize they are not able to correct their mistakes. They realize they are not able to hit their deadline, and then ultimately they will lose their job. Tell me which is worse. Not getting a job soon, not getting your first job as soon as possible, or getting a job and in the long run losing the job and losing out on your career. Which is more painful for a person? Obviously the second scenario. So don't look for shortcuts. Have the guts to face life head on. Have the guts to look at life and treat it the way it is supposed to be treated. Don't get emotional for everything. One company don't get cleared, that day go to the bar. Now don't go anywhere, Corona is there, but you understand what I am trying to say. This is not how you should live life. Okay? So ups and downs will be there. Heartbeat only, if you see it's up, down, up, down. Life will also be up, down only. Why are you bothered? But always seek knowledge, always seek understanding, and this will carry you forward in life. Okay? Anyways, this is clear to all of you. So the next question which I want all of you to, okay, I did not execute this. I'm very, very sorry guys. Let me execute this for you. So yeah, I need a string yes. So I'll just go system.out.println is palindrome, and I'll pass string yes. See, initial value of I is 0, but j should be last index. Last index is yes.length minus 1. Okay. Okay. Yeah. True. Again re-execute. Put something like some ABCD. Not a palindrome. False. Okay, it works. Super guys, so you guys have become Recursion, and there are some funny videos that have seen online, which explains how Recursion is. Some guy will, there is a video of a guy who walks in with a phone and sits on the sofa and then shows the phone again, and inside the phone they will zoom, and again inside the phone the same video of him walking inside the room and sitting on the sofa. Then he will show the phone layers, again there he will be walking and sitting on the sofa. So that is a recursion without a base condition. But I hope you will not write such recursive algorithms. You would have also seen, there are these small toys. Nowadays, kids, I don't know whether they've even seen. And I don't know from which generation you are, Generation Z, X, Y, millennials, there are so many words. So what I was saying is the toy, if you would have seen in childhood, that one small toy, you can open the top and there'll be a smaller toy. Open the top, there'll be a smaller toy. Open the top, there'll be a smaller toy. And then at the end there will be one toy remaining. That toy is only your base condition. From there you have to return.